Hi guys. So today we're going to talk about hopefully the last part of Unit 1, uh, which is segments. We got a lot to cover today. At any point, if you want to go faster, just make sure you fast forward because there's stuff that you still have to put on our chat. So don't skip over those things, okay? Other than that, you guys can go at your own pace. So let's go ahead and get started. So the first thing that I wanted to show you guys is these are some of the vocab words that we are going to cover today, or that we're going to go over today. Okay, we are going to go over every single one as we go. So the first thing that I want to talk to you guys is how I know you've seen it before, back middle school, what a point and what a line is. But now we're actually going to go ahead and put some content or put some stuff to it, right? So a point, okay, so I'll label it a point. So it represents a location, right? So it's like whenever you're looking at a map, you're gonna drop a point or you're gonna point something out. It represents a location, and it has no particular size or shape. So in other words, that little thing is a point. This little thing is a point, so on and so forth, right? So it doesn't really matter. Most of the time, pretty much always, you're gonna just see a little dot, right, or a point, and or a little circle, a filled in circle. What is important is right here the fact that when you label a point or how we refer to a point is you are always going to use a capital letter. And now it doesn't have to be anything in particular. It can be whatever letter you want as long as it is capital. So here I could have called it A, right? So point A. That way we can refer back to this point, right? So if I had another point, call it B. You don't want to use the same, if you're talking about the same problem, you don't want to use the same capital letter. You want to use different letters, okay? But again, A, B, Z, etc., etc. But the thing is, you want to use capital letters, okay? The second thing I want to talk to you guys is about lines, okay? Now I know you know what they look like, right? Whatever. Um, but let's get more precise, okay? So a line is going to be created by any 2 points, okay? So as long as you have 2 points, you can always create a line. So I could have a point here and another point there, right? We'll label it A, B, and I can have a line. Let's pretend that's perfectly straight. I can have a line going through it, right? So as long as you have 2 points, doesn't matter where, how, as long as you have 2 points, okay? As long as you have 2 points, you can always draw a line through those 2 points. And just how we talked about for a point, a line has no thickness, no width. And it goes indefinitely. In other words, it goes on forever on on opposite sides. So it goes on forever to the right, goes on forever to the left. Okay. There's two ways we name a line, right? So the 2 points. So here, this would be line AB. Now you have to be careful. We use the line symbol or the little line over it. Another way we could refer to it is we can use what's called a lowercase script letter. So in other words, it's kind of like a handwriting letter, right? Um, so here, there's two ways I can say line AB with the line on top, or I could have said line L. Okay, those are two ways that we can refer to a line. There's two words or one word really. What that I want to talk to you guys. It's called collinear. Okay, and collinear just means points. Okay, so more than one, or in this case, more than two, right? Points, 3 plus, um, that are on the same line. That's it. So collinear are points that are on the same line. And so non-collinear simply means points not on the same line. Okay. So the next thing I want to talk to you guys is what we call a plane. Okay. Now I know this is hard to see, because it's a little bit more difficult. But picture a frame, sorry, a plane, kind of like the frame of your screen, right? So the TV screen, the flat part, that would be a plane. On your phone, the surface, the touchscreen, that would be a plane, right? So here's my best attempt to draw a plane, right? And know one thing, a plane, just like a line, a plane goes indefinitely in all directions, right? So it goes forever that way, it goes forever that way, forever that way, forever that way. So think about it, if you can stretch it in all directions, that's the directions that it goes on forever. Okay. Notice how it says to name up or to make a plane, it's 3 points on that plane, right? So it doesn't matter how I draw my points, right? As long as they are non-collinear, okay? As long as I have 3 points, I can always create a plane, right? So we label points A, B, C, and I can have another one. Let's call it P, right? It doesn't really matter. So 3 points, know that 3 points make up a plane, okay? And the way you name a plane, okay, there's two ways we name a plane. The first name, which is the one you're going to see the most often, is by using three non-collinear points. Remember, collinear just means not in a straight line, right? So here, let's do this. So if you can kind of see, these 3 points are almost in a straight line, right? So I don't want to use P to name my plane. Instead, I'm going to say plane and then label it A, B, C. Okay, those are three non-collinear. Another way we could see it says upper script letter. Okay, so here's my best attempt, right? Or we could have said plane plane B. Okay, it's uppercase scripted letter. And so just so when we had collinear, non-collinear points, we have what we call coplanar and non-coplanar points. And coplanar means you have points on the same plane. And so you can just imagine non-coplanar points or non-coplanar are points not on the same plane. Okay. And so an example of that is, so here we have 4 points. We have point A, P, B, and C. So a non-coplanar would be out here somewhere, and we'll just call it Q. Okay. So Q would be a non-coplanar point because it's not on the same plane as all these other points. Couple more things. So intersection, right? So when you come, there's two different types of intersections that we have, right? So we have two lines, okay, and two lines. So let's label it line L and line P, okay. So here my two lines intersect, and where they intersect, they create a point, okay. It doesn't really matter what you call that point as long as you use a capital letter. Let's just say I, point I for intersection, right? So here, when two lines intersect, they create a point, okay? Now it's a little bit different when we have two planes, okay? Because think about it this way: if you take two papers, right, pretend those are two planes, if you were to kind of cross them together, if you were to intersect them, the outline that they make is a line, right? So this line right here is the intersection of both of these two planes, right? And so we'll call that line L as well. And so when two planes intersect, they create a line, okay? And that's going to be very important, okay? When two lines intersect, they create a point. When two planes intersect, they create a line, okay? So in geometry, there's things, or in math in general, there's things that we can assume and things that we cannot assume, right? Some of them are pretty straightforward. They're common sense, but other ones you kind of think about it, right? So as far as lines go, if something looks like a line, if something looks straight, then we can assume, it's okay to assume that it's straight. Um, Same with if something looks like it's in the same line, it's something is collinear, coplanar, etc. We can assume that, right? If something looks like they intersect, then it's safe to say that they are indeed intersecting. Um, as far as where something is located, inside, outside, opposite side, etc., etc., vertical angles. I know we haven't talked about them. Okay, these would be vertical angles, or these would be vertical angles. Something looks like a line, and you have two linear pairs, right? So then that's safe to assume. Okay, one I want to talk to you guys about is betweenness of points, right? So let's just say we have, well, for our purposes, let's say we have this, right? A, B, and C. Now, we cannot assume measurements, but what we can say is if B is between AC, then if I were to compare, uh, yikes, if I were to compare um, these two sides, right, I can say that AB is smaller than BC. Not actually measuring, but because I know B is strictly between A and C. Okay, so that one's okay to do. Um, the things that we cannot assume is if something looks the same, we cannot say they look the same. Same with measures. We can't say something is acute, something is right, something obtuse. For an angle, the only time we can say that it's a right angle, like if I told you that's a right angle, we cannot say that. We cannot assume that unless I specifically put the little right angle mark. Okay. Other than that, we cannot assume that that's a right angle, obtuse, etc., etc. Okay. Same for any angle measurements. If I gave you something like this, okay, A, B, and C, but that's all I gave you, you cannot assume that that is the midpoint. Okay, you cannot say that unless I gave you this, right? Because that's telling you these two segments are congruent. Okay, so again, we cannot assume that. Okay, you do need to know most of these for your homework later, but you guys can come back to it after we finish today's notes. So let's talk about what we're going to do today. So we're talking about segment and segment measures. Now, we already talked a little bit about segments, right? Um, so what a segment, I'll just put it right here. A segment is is it's a measurable part of a line, right? So a segment has endpoints. Okay. I don't know how well you can see that. So a segment has endpoints. So let's just say here's start and A, B. Okay, that's a segment. Okay. Now, whenever we're measuring segments, so if we're given a number line, it's pretty easy. All we gotta do is count, right? It's count from one point to the other. So from point A to point B. So from there, so from point A to point B. So 1, 2, 3, 4. So this one we can easily say segment AB measures 4, or it's equal to 4. Okay. Now for this second one over here, we have two particular segments. We have segment AB and we have segment CD. Notice how they're both, notice how they're both, if we count 1, 2, 3, 4, 1, 2, 3, 4. So notice how they're both have a measurement of 4. So we can say because AB is equal to CD, right? Then we can also say that segment AB is congruent to segment CD. Okay, so this here, okay, that's telling us that they're both equal 4. Here, we just want to know that they're both congruent. They're both measure the same thing. Okay, so with that being said, we got one more thing to talk about. Segment addition postulate. I know we mentioned it last time, but we didn't really go in detail. So what segment addition postulate is saying is if you were to take this part here, okay, so if we were to take, sorry, It's even worse. I'm so sorry. Okay. So if we were to take segment AB, right, and we were to add it with the segment from B to C, what does it create? Okay, well, if you take the whole thing, it's going to give you everything from A all the way to C. And so that's exactly what it's saying. That's exactly what it is. So it's saying if you add the two smaller parts, right? If you add this little part and this big part, you add them together, then you get the entire thing. So for example, if I told you that's 3 and this is 5, right? So we would do 3. So if I asked you to find what's AC, well, if I'm trying to find AC, I know that AB, which is, I know AB is 3, and I know BC is 5, which means that AC should be, or it is, 8. Okay, and so we're going to extend that a little bit. So I want you to, in the chat, okay, so I'll put in chat, take a couple of minutes and actually answer these questions. So in the chat, all I want you to put is A, and then your answer, B, answer, C, answer, D, answer, and then move on. Okay. I'll put the answers in. Go ahead and do that, and then in a bit I'll put the answers. If you want to pause it, please pause it so you can try it, and then check your answers. So I hope that you actually paused it. But the answers are here: 37, 4, 7, and 29. Okay. If you got all of them right, you don't need an explanation. Fast forward. If you need an explanation, stay tuned. I'm about to go over all of them. Okay. So for A, PQ, they're telling you this is 9. QR is 28. So if we're looking for the entire thing, all we simply got to do is add both of them. That's how we get 37. Okay. First one, a little bit easy. Part B, it says if QR is 17, okay, so from here to here 17, PR is 21, okay, so the whole thing is 21. It's asking you to find PQ. Well, that one's kind of easy to do because we know the whole thing is 21. We know this part is 17. All I gotta do is subtract and we get our answer, which is 4. Okay, moving on to the next one. Okay, letter C. So for C, they're telling us that PR, so the entire thing is 71. So P all the way to R is 71. And then they're telling you PQ, okay, so this little part is 8x minus 17, and QR is 5x minus 3. And so this is where we apply the definition of segment addition postulate, right? So I'm gonna work it out down here. So what we're gonna do is we're gonna add 8x minus 17 plus 5x minus 3, and we're gonna equal that to 71. Okay, so this right here is our PQ, and then this up here, this here is our QR, right? So PQ plus QR equals PR. And so from there, combine like terms, right? So that would have given us 13x minus 20 equals 71. Add 20, 13x equals 91. Divide by 13 and we get 7. Okay. Give me a minute to erase this. All right. So then the last one, it says if PR, so this entire thing is 14x minus 8, PQ, this little one, is 5, and QR is 9x plus 2, okay? Then is asking to find QR. So to find QR, well, we know QR in terms of x. So in other words, we got to figure out what is x equal, so that once we know what x is, all I got to do is simply plug it in, right? So that's where we're at. So once again, we're going to apply the definition of segment addition postulate. So PQ, so 5 plus QR, which is 9x plus 2, equals the entire thing, which they told me was 14x minus 8. And now I simply solve for x. So combine like terms. So that gives me 9x plus 7 equals 14x minus 8. So I'm going to move this 8 over here, move that 9 over there. So I got 15 equals 5x divided by 5, and I get x to be 3. So now that I know what x is, I simply got to go in here and plug it in. So 9 times 3 is 27 plus 2, 29. Moving on. Go ahead and scan this. If you can't scan it, send me a message in the chat. I will put the direct link to it. But there's 3 questions for you to do, and you got to get them done. So let's talk about midpoint. Okay, so what is a midpoint? A midpoint is it's a point, right? That is going to divide. So a midpoint is going to divide. Yikes, can't spell. Divide a segment in 2 congruent segments, right? And so what can divide well, let me back up. Okay, so let's pretend here A, B, and we talked about this last week, right? If I say this is my midpoint, in order for me to show visually that that's my midpoint, you can't see that, I want to go ahead and make the 2 same marks on both sides, right? So this is telling me AM equals MB, okay? And so the things that can cut a midpoint or cut a segment in half, right? The thing that cuts your segment in half, that's what we call a segment bisector. Okay, so the thing, let's see, the thing that cuts in half. Okay, that is what we call a segment bisector. Okay, so a segment bisector does the bisecting, right? It bisects something. Okay, so let's go ahead and try one problem together. Actually, I want you to try it. Go ahead and pause the video, give it a try, put it in the chat. Okay, so in chat. So I want you to put A, your answer, B, your answer, and then I'll put the answers on here. All right, so I hope you actually paused the video. So here the answers: x equals 6, y equals 8. Okay, so if you need an explanation, stick around. If not, fast forward to the end. And then, so here we go. So for the first one, it says if Q is the midpoint, right, of PR, that means these 2 segments are exactly the same, right? So if PQ, that is 7x minus 16, right? Then, and QR is 4x plus 2. Because we know they're equal, we know they're the same, and the reason we know they're the same is because definition of a midpoint, right? Midpoints tell me that PQ is equal to QR. And so if that's true, if I want to solve for x, that's what's giving me my equation, right? I know PQ is this and QR is this. So simply set them equal to each other. Whoops. Exactly how I have it there. And I solve for x. So I'm going to subtract 4. So 4 goes over there. 16 goes over there. So I got 3x equals... what did I do wrong? Oh, I'm sorry. Notice here I put a plus. That will make so much more sense. This is 18. And so then divide both sides by 3. I get x to be 6. Okay. This last one. Let's see if I can leave it there. Can you see? It's good enough. All right. So it says for this, for part B, it says Q is a midpoint of PR, right? And it says PR, so the entire thing. Oh, I'm gonna go ahead and erase it because this one is a little trickier. Slightly, right? Okay, so it says Q is a midpoint of PR. So PR is 6y minus 2. That is the entire thing, right? And then it says PQ is 4x plus 3. Okay, PQ plus 3. And it says QR is 7x minus 12. Okay, now here there's two things happening, right? First, we got to figure out what is x, because once we know x, we can simply plug it in and figure out what the whole thing is equal to, have another equation, right? And so what we don't do is we don't do a segment addition postulate because we know that this is the midpoint, right? We know that is exactly between both of these two segments. And so since it's between both of these two segments, then we simply set them equal to each other, just how we did the first one. So we have 4x plus 3 is equal to 7x minus 12, and we're going to solve for x. So move the 4x over there, move the 12 over here. So we got 15 is equal to 3x. Divide both sides by 3, and we get x to be 5. And so now that I know that x is 5, once I plug it in into both of these segments, this is 23, right? But remember that these should be the same, right? So if I plug it in here, that's 35. 35 minus 12 is also 23. If we add them together, the whole thing, so the whole thing PR is equal to 46, but we don't want 46. We want to know what y is, right? So we set up our last equation, 6y minus 2 is equal to 46, and we solve for y. Add 2, we get 6y equals 48, divide by 6, and we get y to be 8. All right, last thing, summary. Okay, so we did talk about a lot of things. So let's just, first thing was, and I'm going to take the whole thing, right? A point. How we label it, use capital letters, right? Capital letter. For a line, there's two ways we name a line. Well, first of all, that's a segment, right? And for a segment, we use just one line with no arrows at the end. For a line, so we still have 2 points, right? But in this case, we kind of go past those 2 points and we extend it. So here, and if I label this, let's just, I've been using L, let's just use P. So here we have line AB, but with arrows on top. Or I could have also called it line P, okay? And then we also talked about planes, right? So a plane, let's just, here's my plane. A plane is by using 3 non-collinear points or a capital manuscript letter, right? And so here we can have plane A, B, C in no particular order as long as they are non-collinear, right? Non-collinear. collinear. Okay. And then we also said we can label it plane B. Okay. So then we also talked. So we talked about collinear. We talked about coplanar, right? Coplanar means same plane. Collinear means same line, right? So it's kind of plane, line, etc., etc. Okay. We talked about lines intersecting, right? So if that's line L and this is line R, where they intersect, they create a point, right? Create point. If we have two planes crossing or intersecting, they create, here's my artistic skills, they create a line. Okay, so here, create line. So then we also talked about segment addition postulate, right? And that one was if you have a segment and a letter or a point is between them, then you can take the two smaller parts, add them together, and you create the entire thing, right? And then we also talk about midpoint. Yikes, can't spell. Midpoint, okay? So you have a line, or not a line, I'm sorry, you have a segment. A line cannot have a midpoint because the line goes on forever, right? The midpoint, okay, that's what it means to be a midpoint, right? It divides two segments into two equal parts. So midpoint, here we have AB is the same as BC, okay? And what can do the bisector? So we can say segment bisector. Segment bisector can be either a line, it can be a ray, and it can also be another segment. Okay, all that simply means is that if this is my segment that I'm going to bisect, I can have a line going through it, right? I can have, let me see, use a different color. I can have a ray. Ray starts there, shoots out somewhere, or I can just simply have another segment going through the middle. Okay, that's what we call segment bisector, the stuff that does the cutting in half. Okay, so there is a Schoology assignment on Schoology, and it's up and running. Go ahead and get it done. If you have questions, please unmute yourself, ask, put in the comments. Thanks for being awesome.